back to my channel Bal Vigyan Bharti. We are progressing on trigonometric ratios, and on which we have discussed till now the the part where we have assumed that a rotating arm of radius r, which are pivoted at point 0, the intersection point of the axis, the standard axis x and y in 2D system, and it is making a radius, it is making a circle. The tip of the arm is making a circle, and consecutively it is making an angle of equal size with positive x, positive y, negative x, negative y, and with the different conditions on we have arrived some standard ratios of the angle which are making with the axes. There we have seen the relation between the angles which are made in for the first coordinate, and with the angle, the similar angle which are making with the second, third, fourth coordinates. And from there we have came to know that the sine n into 90 plus theta has to be sine theta if n is even and the complete angle complete angle means the angle n into 90 plus theta comes at coordinate 1 or 2. Okay, if n is odd, then sine of n into 90 plus theta is equal to cos theta if the complete angle is in first or second coordinate. Understood? If n is even, then sine will be sine. The prior sign will depend on whether the complete angle is in first or second coordinate. Sine will be cos, and the complete angle, if it is reaching only up to first or second coordinate, after the complete turn will be positive cos theta. Similarly, the same thing, only thing is that it will be negative sin theta if this condition changes, if it is in third or fourth coordinate, and it is negative cos theta if condition changes, the complete angle is third or fourth coordinate. Understood? Similarly, the only thing I will change, cos of same will be cos of theta, and the complete angle, if it is in first or fourth coordinate, for cos it will be plus cos. Okay, and this cos will be plus sin theta if it is same way in first or fourth coordinate. because in first or fourth coordinate cos is positive. So this will be like that only. Okay. This is the condition for this one if n is odd. You see my language is not changing, only the coordinate is changing. Now it will be minus cos theta if it is in second or third coordinate. It will be minus sin theta if it is in second and third coordinate. Okay, this is the complete scenario of cos. We have seen for sine. Now come to tan. Tan of this is equal to tan of theta when this is in first and third coordinate. Tan will be cot if it is in first or third coordinate. Okay, now tan will be minus tan if it is in second or fourth coordinate. Tan will be minus cot if it is in second or fourth coordinate. Okay, so this thing will change. Understood? So you can see there are relation between sine and cos. Sine either change into sine or change into cos, and tan theta and cot theta. The similar in sec theta and cosec theta. The same relation as it is, because you can say the reverse one, cosec theta by sec theta. The similar way that sine is responding. Sine will be sine when cosec will be cosec if n is even and it is falling in the first and second coordinate. Sine will be cos if it is falling on what? Sine will be cos if it is falling on first and second coordinate if n is odd. Then cosec will be cosec if it is first and second coordinate if n is even. Cosec will be sec when n is odd and it is falling on first and second coordinate, because cosec is nothing but the reverse of sine, and sec is inverse of cos. So this way it will respond same. Cosec will be minus cosec if it is falling from second and fourth coordinate, third and fourth coordinate, and n is even. Cosec will be minus sec if it is falling on. So let me write it, because everything I have written. This is the same way. Sec will be sec if n is even and falling in. Sec is the inverse of cos, so it will be the first and fourth. Sec will be minus cosec if it is n is odd and sec is first. Sec will be plus cosec first and fourth. Okay, sec will be cosec. Okay, and sec will be minus n is even when it is falling in second and third coordinate. sec will be minus cosec if it is in second and third coordinate. Now if I talk about cosec here, so what would be your cosec? Cosec is inverse of sine. So cosec will be cosec where cosec is positive, first and second. So remember, when it is positive, the result won't change the sign, the external sign, it is first and second, same as sine. And cosec will be the result here, it will be sec, positive sec, if it is same way in first and second coordinate. Okay, now it will change to minus when it is in third and fourth coordinate. It will change into minus if it is in third and fourth coordinate. Understood? So this is the total relation between with the coordinate system when the things change accordingly. Okay, so this is the general information when n behaves as a even or odd and falling on the respective coordinates, accordingly the sign will change. I think you must have understood. Now we will move into some other ratios, some you can say the combination of angle. Here we have worked with only single angle, okay, theta. If in case there are sum of angle or the deduction of subtraction of angle, let's say I'm talking about two angle being added, then what would be their ratio? So try to establish the relation. Now if it is the case, now in that case, if I assume a rotating arm with a pivoted O, making a first initial angle of A anti-clockwise, then after moving another angle the same way, that is on the anti-clockwise direction further to the A, B. Now this is the three position. If it is OP, Q and R, let's say, this is the three position of that rotating vector or whatever you say, rotating arm. Now I will drop perpendicular onto this. Let me draw it a little bigger so that drawing can be understood perfectly. This I am extending just to understand the further derivation. So what I do, taking any point, what I have taken R, let's say, from there I will drop here a perpendicular. From here I will drop perpendicular here too. This is Q, say, this is P, PQR. This is also 90 degree. And from there, let me rub the angle. Just remember, this is A, this is B. Okay, now I am dropping perpendicular from here to here. This is another perpendicular, and I am drawing a parallel line with respect to this here. Now let me make you understand the geometry. This is A, I assume this is parallel to this is intersecting line, so this must be A, and this is 90 degree, this complete angle. Now this is A and this is your B angle. So this is 90 minus A, this is 90 minus A, this is A. First thing is over. Now this is B. So this complete angle is what? This is B, because this is 90 degree. So if it is B, this is 90 minus B. Okay, this is 90 minus B. This is A minus B. This is 90. This is again 90. So this is 90. This, for this triangle, this is 90 minus B, and this is 90 minus A plus B, complete angle. Okay. So what is this angle then? This is cumulatively 90 minus B. 90 minus B. So this angle will be this deducted by this 90 minus A minus B. So this will become A. So this angle is nothing but A. Okay, again fine. So this will be 90 minus A. So you understand all this. This we have derived as A. This is 90 minus A. This is A. This is A. Okay. So there is no ambiguity. Now we'll name all this. This is R. This is Q, P, S. Let's say this point. This may be T. What else? Okay. Now why I want to make the, let's say I am taking sine angle of A plus B. Okay, this angle I am just calculating. So I will consider RTO in the triangle OTR. The sine of this is what? This is the sine, means this total by this one. So that means it will become the vertical RT upon OR, isn't it? This vertical by upon this. Okay, now RT complete is can be written as RS plus this up to this plus this RST. You can write it ST upon OR. Understood? Now I am separating this RS by OR plus ST by OR. Okay. Now I have to arrange it such a way that I will get some ratios of the triangles available here. So how will I do that? RS means this one. This can be available in this triangle. So if I consider it on this triangle, RS, I will bring such a way that the thing I will bring, which will be arranged with OR also. OR means this one. So OR also coming in this triangle. So in this triangle, what is the side? This is common to this and OR. This side can be common to this for this triangle, and with OR this will be common for this triangle. Both are right angle triangle. So let me take RS upon RQ. Okay, I'm bringing RQ. RQ is common for this triangle with OR and common to this triangle with RS. So if I bring something RQ, it won't change if I do it for numerator and denominator both, isn't it? So I am keeping RQ over RS. So similarly, I will try to bring something here also. So ST is a part of a triangle, is not a part of any triangle individually. So if I compare, as because this is parallel to this, these are vertical, so this is a parallelogram. So we can say that ST is equal to this RP. We can write, we'll write it QP by, so I will take another step to complete it. Now okay, let me give it here. RS by RQ. RS by RQ. For this triangle, if it is signed, so RS by RQ, if it is A angle, so this will be cos A. RS is the base, RQ is the hypotenuse. For triangle, this is right angle because this is parallel. This is to this. If it is 90, this must be 90. So RS is the base of this triangle and RQ is the hypotenuse. So this is the cos of this. So I can straight away write cos A. What is RQ by OR? Let me check. RQ by OR for this triangle. This is B. So B with a B triangle, this is right angle triangle. So RQ by OR is what? Sine of B, if I take, this is vertical by hypotenuse. This is sine of B. Still the second part is there. QP can be divided into QP by, the common for OR is OR by this side is common for this, both this and this. So I can bring OQ here. So if I want to bring OQ here, QP by OQ I am bringing into OQ by OR has to be there. So let me rub with a part of here. So now ultimately this will be cos A, I am writing it again here again, plus QP by OR. What is QP? QP this one by O, QP by OQ, sorry, QP by OQ. This comes in the right angle triangle, this is 90 degree. This is, if I take sine of this, so QP is the vertical by your hypotenuse. This is the sine A. So I can write this is sine of A. Now OQ by OR. OQ means this one and OR for this triangle, this right angle triangle. OQ means the base, OR means hypotenuse. This is the cos B. I can write cos B. Understood? So it stands sine of A plus B is equal to cos A sin B, sin A cos B. So if I want to arrange it in a systematic manner, so as it is sine, so I will start with sine A cos B, the sine of first angle, cos of the second angle, plus sine cos of the first angle into the sine of the second angle. So I want to arrange to memorize easily. So what will you memorize when it is started with sine? So sine angle of first angle will come first along with the cos B for the first part. Second part automatically both will be reversed. So sine A plus B, we can remember it as sine A cos B, cos A sin B. Okay. So this is the derivation for the sine A plus B. In the further videos, we will also show what is the cos, what is the tan, and what is the sine A minus B also. Both all of this derivation I will show you slowly in the respective videos, further videos. Okay. So thank you for now. Keep watching my videos. Do subscribe. Please influence your people to subscribe my channel, because I am trying hard to help the students who are still studying in classes from 6 to 12. Thank you.